Hello everyone, welcome back to my channel. My name is Dr. Yogita Bisht and in today's video we will talk about Aufbau Principle. This is the second video of my video series Electronic Configuration. In the previous video we talked about the different type of quantum number. Without the information of or the knowledge of these quantum number, you won't be able to understand the concept clearly. So I would suggest you to watch that video. I'll provide the link for that. Okay, so let's just start with this. What is Aufbau principle? So this Aufbau, it may seem to be a little alien to you. Why? Because this is not an English word, it is a German word. Das bedeutet etwas zu bauen. It means to build something. Okay, and this principle literally work on that concept that we build the entire electronic configuration step by step. Okay, we apply certain rule and then we build the entire configuration. Like, so there in atom we have so many electrons and so many orbitals, so in which orbital the electron should move first, this principle talk about that. Okay, so it says, number one, the rule, it says that the electron move to that orbital first which has a lower energy. This is the first concept of this principle. Okay, now how do we get to know that which orbital has a lower energy, which one has a higher energy? So it provide a rule for that. It says if n plus L has a lower energy, lower value, then its energy is also lower. This is the second point of this principle. Now there can be a certain cases where n plus L of one orbital has the same value as that of the n plus n value of the other orbital. In that case, it says when two orbital have same n plus L values, then the orbital having lower n value will have lower energy, and that is it. These are the three concepts of the Aufbau principle. If you understand this properly, you will be able to fill the electron in in different orbital easily. Now let's just start with the application of these rules. Okay, before we move further, I would like to give a very short recap of what is n, what is L. N is basically the principal quantum number and it can have any positive integer value, +1, +2, +3, anything. Okay, and what about L? L is the azimuthal quantum number and L can have any value 0 starting from 0, 1, 2, so and so till n minus 1. What does it mean? It means when n is 1, L is going to have a value of 0. Okay, when n is 2, L is going to have 0, 1 till n minus 1, right? So 0, 1. When n is 3, L is going to have a value of 0, 1, 2. And these value have a specific name. When L is 0, this has a name S. This is S. When L is 1, this has a name P. So this is S, this is P. When L is 2, its name is D. And when L is 3, its name is F, and so and so. Okay, so this is a short recap. If you want to study this in detail, you can just watch the first video of this series. All right, so let's just start applying these rules. Okay, so we will start with n is equals to 1. We are going to calculate the L values and then we are going to find the n plus L value and then of course the energy level. All right, So for n is equals to 1, we know that L possible L is only 0. So 0 plus 1 is of course 1 and this is 1s. Okay. When n is 2, L can have either 0 value or 1, right? So n plus 1 would be 0 plus 2, that is 2. So this is 2s and this is 1 plus 2 is equals to 3. This is 3. This is 2p, sorry. Let me just erase this. Okay. So this is 2s and this is 2p. I hope you are getting this from where I'm writing this. 1, 2, 3. These are the value for the principal quantum number. Here the principal quantum number is n1, right? And this s is coming from the azimuthal quantum number, that is 0 here. So s. For n is equals to 2 and L is equals to 0, we have 2s. For n is equals to 2, L is equals to 1, we have 2p. Okay? Alright. Then for n is equals to 3, the possible values are 0, 1, 2, right? So in that case, n plus L would be 0 plus 3. So this would be 3. Here 1 plus 3, 4. Here 2 plus 3, 5. So no point of guessing the values for this. So this is 3s, 3p and 3d, right? Similarly, for n is equals to 4, we have 0, 1, 2, 3. So it is 0 plus 4, 4, that is 4s. This is 1 plus 4, 5, that is 4p. This is 2 plus 4 is equals to 6, that is 4d. And this is 3 plus 4, 7, that is 4f. Okay. So I hope you are not getting confused. Here instead of n, I have written the L values and here I have written the n value. If you want, we can just replace that also. It doesn't matter because we are talking about the total sum, right? So this I can write it as L and n so that this table create no confusion at all. All right. So here you can see the sum values over here. So it is very obvious that this L plus n value has a lower value as compared to the next one. So obviously 1s has a lower energy as compared to 2s. Okay. Similarly, next we have 2p and 3s. Now 2p also has n plus n value 3. This also has n plus L value of 3. Now which one should have a lower value? Then in that case, we will go by the rule third. This rule says when two orbitals have the same n plus L values, then the orbital having the lower n value will have the lower energy. So out of these two, which one has a lower n value? Of course 2p. So that is why the next energy level that is going to get filled is 2p. Then we have 3s, right? Now next is 3p and 4s. So if I compare 3p and 4s, of course both have the same n plus L value. Now which one should get filled? Of course 3p. Why? Because the n value is lower. So the next value that we are going, next orbital that we are going to fill is 3p. Then 4s. So you can see I have skipped the 3d. Why? Because its n plus L value has a higher value, right? Now in next case also, should I write 3d first or 4p because both has the same n plus L value? So in this case 3 is lower than 4, that is why 3d is going to fill first followed by 4p. So in this way you can fill the rest of the orbital. So this is the sequence of the increasing order of the orbital. So if we are talking about multi-electron system, any oxygen, iron, any question, any example, then depending upon the number of electrons, first we will fill 1s orbital, then the 2s, then 2p, then 3s, then 3p, then 4s, then 3d, and then 4p, and so and so. All right. So I hope that was easy to understand. Okay. Now in exam, what is going to happen is you need not to write the complete table or mug up all this table. Okay, there is a easy diagram to remember this. Okay, so we can do that also. Okay, so I'll start with that first. Okay, so the easy way to remember this is, first you are going to write all the orbitals name. So I'll start with 1s. Okay, tip to remember the sequence of energy level. Okay, so I'm going to write 1s, then 2s, 2p. Why? Because for 2, the only possible or combination of L is 2s and 2p. Then we have 3s, 3p, 3d. So in case of 3, only s, p and d are possible. Then we have 4s, 4p, 4d, 4f. Then we have 5s, 5p, 5d, 5f. 5 can have other orbital also, but we don't while writing this tip, we don't go beyond f. Then we have 6s, 6p, 6d. We can also write 6f. Then we have 7s and 7p. Okay, we can write rest also. Okay, but normally we don't fill to that level. That is why these are enough. Okay, then what you are going to do is draw arrow around it. Okay, this arrow, then this arrow, then dotted, this arrow, then keep on drawing the diagonal arrows around it. Okay, and trust me, this particular diagram comes out to be very handy to remember all these configuration. Why? Because for simpler up to 10 or 12 electron system, it is easy to fill, right? But for the complex one, it is difficult to remember the sequence. Okay, so once you have the diagram, what you have to do is just follow the direction of the arrow. So the first value says 1s, right? Then the next, follow this dotted line, and then arrow, it says 2s. Next, follow the dotted line, this says 2p come first, and then 3s. So we are going to write 2p, then 3s. Then the next arrow, the dotted line says 2p, 3p followed by 4s. So it is 3p, then 4s. Then next we have the dotted line has 3d followed by 4p followed by 5s. So it will be 3d, 4p and 5s. Okay, similarly we have 4d, 5p, 6s, 4d, 5p, 6s and so and so. Okay, so with the help of this diagram, you need not to mug up this particular sequence. All right. Okay, so let's just do a quick example. Okay, so it says carbon has atomic number of 6. Okay, so we have to write down the configuration. Okay, and remember each orbital can have maximum 2 electrons. Okay, so as per this sequence, the first electron should go into 1s orbital. So 2 electron, it can hold maximum 2 electrons. So first 2 electrons are going to move into this. So the remaining electrons are 4. Next is 2s. So it is also going to have 2 electrons. So the remaining electrons are 2. Next we have 2p. So though it has a capacity of holding 6 electron, the 2p in total, but the electron left are 2, right? So this is the electronic configuration of carbon: 1s2, 2s2, 2p2. Okay, I started with a very simple example. Okay, why? Because we have not studied the Pauli exclusion or the Hund's rule yet. So once we know about all the principles, it will be easier for us to apply those and write the correct configuration. All right, so I hope you find this particular video helpful, and if you have any doubt, you can comment down below, and then I'll see you in the next video. Thank you.